Hello all, welcome to the day 79 of the daily case study series for CBSE grade 12. The question goes like this. In the given figure, the vector equation of the lines in the extreme sides are r vector is equal to I minus 2j plus lambda times I plus 3j plus k, and r vector is equal to I plus j plus lambda times I plus 3j plus k. Now from these two lines, what we understand is the direction vectors are equal. That is, the two lines are parallel to each other. Suppose these are the two extreme lines. There are 8 lines between the two extreme lines, and the distance between any two consecutive lines are equal. The red lines represent those 8 lines. The spacing between the lines are equal according to the question. Based on the given information, answer the following questions. Question A. Find the distance between any two consecutive lines. To get that distance, let's get the distance between the two extreme lines, and these two lines are parallel. From the first extreme line, we get A1 as I minus 2j and B1 as I plus 3j plus k. From the second extreme line, we get A2 as I plus j and B2 as I plus 3j plus k. Now, because B1 and B2 are same, let's call it by the letter B itself. To calculate the distance between these two lines, we use this formula: absolute value of the magnitude of B vector cross A2 minus A1 by the magnitude of B vector. Here A2 minus A1 is 3j. Let's calculate B vector cross A2 minus A1. I times 0 minus 3 minus j times 0 plus k times 3, which is minus 3i plus 3k. Then magnitude of this cross product is square root of minus 3 square plus 3 square, which is 3 root 2. Magnitude of B vector is square root of 1 square plus 3 square plus 1 square, which is root 11. So the distance is equal to 3 root 2 upon root 11. On rationalizing this, we get 3 root 22 upon 11 units. This is the distance between the extremes. Between the two extreme lines, we have 9 tracks. So this total distance has to be divided by 9. Distance between two consecutive lines is 1 upon 9 times 3 root 22 by 11, which is root 22 upon 33 units. Question B. Find the perpendicular distance between the position of the winning player and the finishing line. So in the diagram we see this is the finishing line. Let's call that as BC. Finishing line is BC. The position of the winner BA. If the Cartesian equation of the finishing line is given by this, and the position vector of the winning player is given by 2i plus 3j minus 3k. The position vector of the winning player is 2i plus 3j minus 3k. That is, the coordinates of A is 2, 3, minus 3. And the equation of finishing line, that is BC, is given by 7 minus x is equal to 3y minus 2 is equal to 1 minus z, which can be taken as lambda. Here we have to find the perpendicular distance between the position of the winning player and the finishing line. That is, if we drop a line perpendicular to BC, meeting BC at D, we have to get the distance of this line AD. For that, we need the coordinates of D. That is 7 minus x is lambda, 3y minus 2 is equal to lambda, and 1 minus z is equal to lambda. So from this we get x as 7 minus lambda and y as lambda plus 2 upon 3 and z is 1 minus lambda. The coordinates of D are 7 minus lambda, lambda plus 2 by 3 and 1 minus lambda. But we have to get the value for lambda. From this equation, that is the equation of BC, let's try to get the direction ratios of that. Writing this Cartesian equation in the standard form, we get x minus 7 upon minus 1 is equal to y minus 2 by 3 upon 1 by 3 is equal to z minus 1 upon minus 1. So the direction ratios of BC is minus 1, comma 1 by 3, comma minus 1. Similarly, let's get it for AD. Direction ratios of the line AD is 7 minus lambda minus 2, comma lambda plus 2 by 3 minus 3, comma 1 minus lambda plus 3, which is equal to 5 minus lambda, comma lambda minus 7 upon 3, comma 4 minus lambda. Since AD is perpendicular to BC, A1 A2 plus B1 B2 plus C1 C2 is equal to 0. 5 minus lambda times minus 1 plus lambda minus 7 upon 3 times 1 by 3 plus 4 minus lambda times minus 1 is equal to 0. That is lambda minus 5 plus lambda minus 7 upon 9 plus lambda minus 4 is 0. On simplifying, we get 19 times lambda is equal to 88 and lambda is equal to 88 upon 19. Substituting the value of lambda in D, we get 7 minus 88 upon 19, comma 88 upon 19 plus 2 by 3, comma 1 minus 88 upon 19. On simplifying this, we get 45 upon 19, comma 42 upon 19 and minus 69 upon 19. AD is that perpendicular distance between the winner and the line BC. This is equal to x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square, which is 45 upon 19 minus 2 the whole square plus 42 upon 19 minus 3 the whole square plus minus 69 upon 19 plus 3 the whole square, which is equal to root 418 upon 19, that is 20.45 upon 19, which is 1.08 units. So this is the perpendicular distance of the winner. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi for more smart learning videos. See you all. with another case study question tomorrow.